In this video, I want to explain why the indirect effect in a path model is given as the product of two or more regression coefficients. Here you can see a very simple path model with three variables, x, m, and y. X is a purely exogenous or independent variable. It is not influenced by other variables, but it does have an effect on m and y. M is a so-called mediator variable, which serves as dependent and independent variable at the same time. M is a dependent variable with respect to x and an independent variable with regard to y. So it serves to mediate the effect from x to y. Y is a purely dependent or endogenous variable where y is influenced by m and x but does not itself have an influence on any other variable in this model. Now this path model here has one independent or one purely independent or exogenous variable x and two dependent variables, and as a result we have two structural equations here, or two regression equations. One is the equation for y, that is a linear regression equation with an effect of x that is given by beta yx, and an effect of m, which is given by the coefficient beta ym. In addition, we have an intercept beta y0, and we also have a residual term epsilon y, which characterizes effects in y or influences on y that are not due to x or m in a linear regression. We also have an equation for m because m is also a dependent variable. M only depends on x, so it's a bivariate linear regression model with an intercept beta m0 and an effect beta mx that shows whether x is linearly related to m, and a residual term epsilon m. Now, the direct effect of x on y in this model is seen here, so that's given by the regression coefficient beta yx. We also have an indirect effect from x to y that is mediated by m, and so this indirect effect is quantified mathematically in terms of the product beta mx times beta ym of those two regression coefficients that are en route, so to say, from x to y. Now, why is that the case? Why is that correct, or why is this the correct way to measure the indirect effect numerically by this product of coefficients? Why is it not the sum of those coefficients or something else? So let's take a look at that. How do we get this to be the product for the indirect effect? In order to understand that, we can look at the regression equations in a little bit more detail. So here again we have our equation for y, and then here's the equation for m again. And so you can see that we have m in the first equation, and then m is given by a bunch of terms in the second equation. And so now what we can do is we can insert what we have for m in our second equation into the first equation for m, and then we can rearrange the terms and we can see what we get. So what happens when we do that? So when we put in what we have for m in the second equation, that's the term here in brackets in the middle. So that's what we have for m, that goes in here for m. And then once we expand that and rearrange the terms a little bit, we get this pretty ugly looking, pretty long looking equation at the bottom for y. So now we've turned our mediation model into a single equation model, right? So that we no longer have two equations, we combine the two equations into one, and that's legitimate, that's mathematically okay to do. It looks bad, but when you take a closer look at it, you'll see that it's actually helpful to understand why there's a direct effect of x and an indirect effect of x, and how those effects are being quantified in this mediation model. So first of all, here we have at the beginning we have simply a complex intercept term. So the sum of those betas here, that's just a complex intercept term, so we can forget about that for now. And here we have the direct effect of x on y, beta yx, so that's one effect that x has on y, and now x, you can see, appears in the equation once more because it's also influencing M, and so that effect that X has on M is now included here in this equation, and so that's given here, and so that then must be the indirect effect, because the direct effect is already given by this direct path beta yx, and there's no doubt that this is the direct effect. This is the indirect effect, and you can see it's the product beta ym times beta mx. So now it's clear that this is the correct way to measure the indirect effect. And then at the end, what we get is a complex error term. So this shows you, first of all, how you can turn a multi-equation mediation model, so say, into a single equation mediation model where you only look at your final outcome variable. And then it also shows you that there's a direct effect of X and an indirect effect of X that are both in the equation now. And you can now also compute the total effect. The total effect is the sum of the direct effect plus the indirect effect, meaning it's the sum of beta yx plus beta ym times beta mx. I hope you found this helpful to understand mediation models a little bit better. If you like these sorts of stats tutorials, then please subscribe to my channel, and I'll see you next time.